Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 23 from the May-June 2019 Edexcel IGCSE Mathematics A paper 2H. This is the higher paper. It says Boris has a bag that only contains red and green sweets. Boris takes at random 2 sweets from the bag. The probability that Boris takes exactly 1 red sweet from the bag is 12 out of 35. Originally, there were 3 red sweets in the bag. Work out how many green sweets there were originally in the bag. Show you're working clearly. Okay, so you have here red sweets and you have green sweets. Now, they've told us that there are 3 red sweets originally in the bag. And we have to work out how many green sweets there were originally in the bag. So a good idea would be to call the number of green sweets X. Okay, so the number of red sweets is 3. The number of green sweets, let's call it X. Okay, so we can say that the total number of sweets is going to be X plus 3. That's the total number of sweets altogether in the bag. All right, now they're taking sweets from the bag, so we assume that they take a sweet and eat it. So we can say that this is going to be without replacement because you're going to take 2 picks. So it doesn't mention with replacement or without replacement, but because we're talking about sweets, he's going to take a sweet, he's going to eat it, he's not going to put it back. So without replacement, we're going to talk about. So he's going to take 1 pick, all right, and then he's going to take a second pick without replacing the sweets back in the bag. All right, so now they've told us that the probability that Boris takes exactly 1 red sweet from the bag is 12 over 35. So we got a situation here where we have a first pick and a second pick. All right, so for both picks, the probability, so I'm going to draw a little probability tree here. For the first pick, the probability in both cases is going to be either red or green. And again, for the second pick, it will be the same. Well, let me make a bit more space here. It's going to be the same 2 options. So you're going to have either he's picked a red sweet or he's picked a green sweet. Okay, and for the second pick, again, either he's picked a red sweet or he's picked a green sweet. If it's a green first, either a red or a green again. All right, so either a red or a green again. So I'm just trying to make it look a bit neat. Okay, so if you draw a tree here, it will help. Okay, so that's the first pick and that's the second pick. All right, so now red, green, red, green. So we've got the outcomes. 2 reds, red, green, red, and green, green. Now let's write down the probabilities. Now we have, for the first pick, we have 3 reds in the bag out of a total of X plus 3 sweets. 3 red sweets out of a total of X plus 3. So the probability of picking a red on the first pick would be 3 out of X plus 3. And the probability of picking a green, okay, would be X over X plus 3. Because X stands for the number of greens. And then the probability of picking another red, we don't really need this probability for this question, but I'm just going to put all of the probabilities there, just for our information. So the probability of picking a second red after we pick the first red, well, there's 2 reds left if we picked 1 in the first pick, because it was 3 first. So it's 2 out of, and there's 1 less sweet altogether. So instead of X plus 3 sweets, they're going to be 1 less, which is X plus 2 sweets. And if we picked a red first, the number of greens will still be the same. There will still be X greens, but there will be 1 less sweet altogether because the first pick we already picked a sweet out. All right, and similarly, if we picked a green first, the number of reds will still be 3 out of a total of X plus 2 sweets. But if we picked a green first, then the greens, there will be 1 less green, so there will be X minus 1 over 1 less altogether, X plus 2. So those are all the probabilities of what happens on the second pick given what happened on the first pick. So if a red was picked first, then that will be the probability of picking a red second, and so on. So now we got to find the combined probabilities. Now what we're interested in, this is picking two reds. We're not interested in picking two reds. This is picking two greens. We're not interested in picking two greens because we want to have exactly one red sweet at the end. Now that will occur if we picked a red first and then a green, or if we picked a green first and then a red. So we need these two outcomes combined, and we know that these two outcomes combined give us the answer 12 over 35. So combining these two outcomes will give us 12 out of 35. All right, so how do we combine outcomes? Well, we go along the branches. So to find the probability of red, green, we go red and then green. To find the probability of a green and the red, let me just do something here to make it clear. Red and green. All right, to find the probability of a green and then a red, we've got to go green and then red. Okay, so those two probabilities combined give us 12 over 35. So to find the probability of a particular outcome, to find the probability of red and then green, okay, we multiply along the branches, and to combine different outcomes, we're going to add the probability of the other outcome. So any probabilities that you want to find a particular outcome, we multiply along the branches. To combine outcomes, which we have to do here, we're going to add those two different outcomes. So that's the sum of those will be 12 over 35. So now let's see how to get probability of red and then green. That's 3 over 35 times x, 3 over x plus 3 plus x over x plus 2. So 3 over x plus 3 multiplied by x over x plus 2. That's the probability of red and then the green. Plus the probability of green and then red will be x over x plus 3 times 3 over x plus 2. And that will give us 12 over 35. What you'll notice in these cases, that these two will both have the same probability. So one of them doubled will give you the answer, because you see they're the same. This is 3x over x plus 3 times x plus 2, and that's also 3x over x plus 3 times x plus 2. So basically you end up with 3x over x plus 3 and x plus 2 plus 3x times x plus 3 times x plus 2 equals 12 over 35. So we have like this algebraic fraction equation to solve. Well, these two together have the same denominator, so we can add the numerators. So you have 6x over x plus 3 times x plus 2 equals 12 over 35. And now we can continue. Okay, I can divide both sides of this equation by 2, in which case this will become 1 and this would become 2. Sorry, by 6, not 2. By 6, that will become 1, that will become 2. And I can then cross multiply, so I can say 35 times this, that will be 35x equals, and 2 times these two together, x plus 3 and x plus 2. And now we can try to solve this quadratic equation we're going to end up with. So on this, let me just write this on the left side. So you got 2 times x squared plus, if we expand this, you can find the sum of those two to give you the middle term, and the product for the last term, x squared plus 5x plus 6 equals 35x. So we have 2x squared plus 10x plus 12 equals 35x. Let's bring the x's together. So everything on one side, 2x squared minus 25x plus 12 equals 0. To factorize this, we could split up the middle term into two parts. We could use our little window technique, which I like to use to split the middle term. It's the same thing, but just more visual. So I'm going to put the top left corner, the 2x squared, and the constant plus 12 on the bottom right. I'll find the product of these two, which is 24x squared, and the sum of these two numbers must multiply to give you the same as those, and these two numbers must have a sum the same as that. So the sum has to be negative 25x squared. So it looks like they both have to have the same sign. They're both going to be negative, so it looks like it's going to be negative 25x and plus x. Right? Is that right? negative 24x and plus x, not negative 25. You have to have a product of 24. So they both have the same sign, sorry. So they're both negative. What am I talking about? They're both negative, and they're going to be 24x and 1x. Sorry about that. They add up to negative 25. They multiply to positive 24x squared. Okay. So here we can see the common factor from these two terms is going to be 2 and x. 2x times x gives us 2x squared. 2x times minus 12 gives us minus 24x, and x times minus 1 gives us minus x. So we have our factors are 2x minus 1 and x minus 12 equals 0. So either 2x minus 1 is 0 or x minus 12 is 0. So x can either be a half or x can be 12. Now the number of sweets, okay, must be an integer. Okay, has to be a whole number of sweets. Must be an integer. Therefore, x is equal to 12. So therefore, the answer is 12. Green sweets is 12. There are 12 green sweets. Okay, so that's one way of answering this question. Now, when we got to this stage here, if you were like, this question is towards the end, you're short of time and you didn't know, or you got a bit of a brain freeze when you tried to factorize it, and you're doing a calculator paper as this is, then you could actually just use your calculator to find the answer and then kind of like make it look like you factorized. So you could have this, I'll just show you from the beginning. Supposing you had your calculator and you want to solve this quadratic equation and you don't have time, you can go menu, go down to where it says solving equations, which is this one. You press equals, and then you want a polynomial. It's a quadratic polynomial, order 2, okay, degree is 2 because it's got a quadratic, the highest power is squared. Then you put down the coefficients of x squared, which is 2, press equal, the coefficient of x, which is negative 25, press equal, the coefficient of, or the constant term, which is c, 12, press equals, and when you press equals again, it gives you one solution, which is 12, and press equals again, it gives you the other solution, which is half. So those are the solutions we found. So you could have left this gap, wrote down these answers, and then worked backwards. So if x equals a half, that means 2x minus 1 equals 0. There's actually another step you could write down here. Whoops, the whole thing is together. So what you could have done here is you could put x equals a half at the end, and you could have written down, you know, this means that 2x equals 1. So 2x equals 1, 2x minus 1 equals 0, 2x minus 1, and x equals 12, x minus 12 equals 0. So you can work backwards. You can put your answer at the bottom here and work backwards. It looks like you factorized. The traditional other way of factorizing, okay, some people might not be familiar with this kind of grid. It's the same thing. You find two numbers multiplied to give you the sum of the product of those two, which is negative 25 and negative 24, positive 24, and the sum has to be negative 25. So the product of these two, which is positive 24, and the sum of negative 25, well, that would be negative 24x and negative x. And then we can take out the common factor from here, which is 2x, and you have x minus 12 minus 1 times x minus 12 equals 0. So then you end up with 2x minus 1 times x minus 12 equals 0, and the rest is the same as this, okay, once you get to that point. Okay, so there's a few different ways I've shown you here, and if you have a calculator paper, you can, if you're short of time, you know, try to show that you factorize working backwards, but don't just write down x equals a half, x equals 12. You're going to lose a mark, definitely, at least 1 mark for that. Okay, if you just write down the answers. If you write this and then these two, they will assume you use a calculator, which you're not supposed to do. You're supposed to use factorizing or completing the square or using the quadratic formula, right? So you should show one of those steps. But if you get like stuck, then this is a way of dealing with it. Makes it look like you factorized. Okay, so there we have the answer to this question, question number 23 from the Edexcel IGCSE Mathematics 4A paper 4MA1 paper 2. This is the higher paper from May-June 2019. Other questions that I have answered from this paper will be in the playlist that will appear in this section over here. If you don't find a question that you want me to answer, you can just send me a request and I will try to do so as soon as I'm able to. Other questions which dealing with probability from the topic from the Edexcel IGCSE papers, you can find it in the playlist over here. And questions dealing with probability for my Cambridge collection, I'll put in the playlist in this section. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.